Hey everyone! Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome Letitia Parcalabescu. Letitia is the creator of the AI Coffee Break, one of the most impactful educational channels out there, YouTube channels out there on machine learning papers and explaining the core ideas behind them. Letitia is also about to complete her Ph.D. at the University of Heidelberg, where she's published amazing works on interpretability, multimodal, and all sorts of exciting things. Letitia, thank you so much for joining the Weaviate podcast.
Thank you so much for inviting me. It's a pleasure to talk to you.
Awesome. So I was really hoping that we could kick things off. We both have had this background of, I also was doing my PhD and then making these research paper summaries, and you've been doing that as well. And I've always been kind of, looking at your content, learning from how you see these things. And I'm really curious, just like, your evolution into creating machine learning YouTube videos and just, how you approach it.
Yeah. Well, I'm a fan of your channel, so I've been watching your channel very closely when you were publishing more videos. Now you kind of don't publish that often anymore, but every time you publish something, I watch it. And so I think you have been an inspiration for me doing that. Like I saw your channel when I was getting started, and yeah, it was the COVID times, and I was thinking, well, I'm teaching at university. I'm producing lectures about, I don't know, self-supervised learning, variational autoencoders, GANs, and so on. And I felt, wow, this is cool. And I could just publish the video recordings of my lectures on the internet. But then, well, there was this consideration. It's, whether the university is fine with that. And I said, like, oh, okay, you know what? I just will do something completely orthogonal to that. I will not do the lectures. I will just do something even better. And especially when it comes to understanding AI, not a lot of people have time to invest 2 hours to understand a paper. Therefore, when I approach content creation on YouTube about AI, I want to keep it like 20 minutes max, or 15 or 12 minutes, and give the key idea, give really the insight that helps a person that has already a little bit of background into what deep learning is, get the idea. And then if somebody wants all the core details and even like the nitty-gritty details, they really, of course, can look into the paper, and I don't have to spend 2 hours going through every single line of the paper. And to really get the concept across, it's nice to do visualizations. And especially at the beginning, I was a little bit shy and I didn't want to show my face. So I invented this coffee bean character. And also what I like about her is that she can do all the silly stuff and I can be serious. And I think it worked out great. And especially for a PhD student at not the world-known university, it creates some notoriety and some talk around one's research, because it's not like I talk only about other people's research. I sometimes also talk about my own research, and it's been a great and wonderful experience. Thank you to all subscribers and followers. They're really nice, and the comments that I get, they're always motivating, and especially in the times of COVID, where there was so little possibility to interact and have this social experience in research, it has been tremendously helpful.
Oh, that's awesome. There's so much I love about that. I guess, also like kind of the university lectures. For me, it was we had our university deep learning class, and sort of in the last 4 weeks, the professor was like, had a list of 40 papers, and everyone was to prepare like a 10-minute presentation of it. And for me, that part was just so much fun that's when I was just going to keep doing it. And also I was pretty shy as well when I started the YouTube, and it would no little face in the corner that I'm doing now, and just recording them. So I really wanted to. So maybe one more detail is for people out there who are maybe thinking about making videos like this is I'm very curious about your use of animations and illustrations. I remember you were explaining the token former, I think, one of these new tokenization strategies, and just like something that I remember just throughout one of your videos that had really helped me a lot. And because you really like visualize this new approach to tokenization, and sort of maybe contrasting that with how maybe Yannick Kilcher does it, how he like has the paper and he sort of like writes on the paper. So I'm curious how you think about like, does making these animations, do you think about like, maybe I want to just get the technical ideas out as fast as possible, or because I imagine it probably takes a bit longer to also animate it all out. Just how do you think about that scale?
Yeah, so it's basically the question of how much production value one wants in a video. And if you look at YouTube these days, it's a little bit like television. There are a lot of channels that have such a production value that even television channel established ones don't reach. And it's crazy. But people have, when they're conducting surveys on where, or when you're looking at how much followership a channel reaches, people have seen that authenticity, and sometimes also seeing somebody makes silly mistakes is actually something that forms a connection to the viewer, because the viewer is this imperfect human, and when this imperfect human watches a perfectly well done video, then they're like a little bit intimidated maybe. And the thing I like about Yannick's videos is that you really are like with him or besides him
Mm.
on this paper, and he sometimes rambles, he sometimes like makes mistakes and corrects it afterwards. But that's exactly something that I would do as well if I would to do this thing in his place. And also when I'm following him and seeing, okay, he did a mistake, I can correct him, or then I can learn something from how it would have been to go into this incorrect path of thinking. So this authenticity is actually really great, and he has shown that you don't need production value, and you don't need to edit a lot, and you don't need to to show your face and do nice animations to be successful on YouTube. Then that's for sure. But it is a personality thing, because when I was thinking, like, what do I want to do that, I mean, I could imagine myself doing that. It's just that especially when I started, I'm a perfectionist, and I was more of a perfectionist than I was back then. And I wanted it to be exactly like edited, and no mistakes and so on. And yeah, I then learned that if I want to publish a video like in the next month, I need to at the time just say I'm done. And when you're done, sometimes there's still mistakes, and you push it, and then you realize, oh, it's a mistake. You you cry about it like a week, but it's like you have. So what I had to learn is leave this perfectionism aside, and just know that 80% of the work is still enough to have a positive impact to many viewers, and so that many viewers can learn from it. And the rest of 20% I would call is content creation or overfitting, because I can create the perfect video for me, or I can create the perfect video for you. But it is really hard to create the perfect video for me and you, because we have different backgrounds, and you maybe need an introduction into, I don't know, Laura, and I wouldn't need an introduction to Laura just because I read it. And yeah, just an example. I think you know about Laura, but it's this idea that the rest 20% you cannot make to fulfill the needs of an audience that is as broad as the entire world. So I thought, like, I'll do my best. I'll do it a little bit like I would explain something to myself or something to my peers. And if somebody has other needs, there's other channel they can watch. There's other papers, or they can just read the papers. So yeah, and then, like, I wanted to do it perfectly, so at the beginning at least, and I started to edit, and I wanted to do visualizations. And in the end I realized, well, maybe that's not all needed. But if I want to keep it short, if I want to keep it at 15 minutes, actually it's needed that you edit and shrink it down. It's important that you don't ramble. It's important that it's very well prepared and scripted, and to bring across really complicated ideas, sometimes with a lot of linear algebra and so on, thoroughly, you need visualizations, and some weird doodles are maybe not exactly bringing it across in 15 minutes. Yeah, so this short form, I think, needs a lot of polishing. And to make it an hour, like Yannick talks about a video, then I think it's totally fine for anybody who has time and also wants to go into all the details of the paper. It's good to do that. So I would say it's good that both these approaches exist, and I wouldn't say one approach is better than the other, because they all have pluses and also drawbacks. Yeah.
Amazing. It's so interesting to hear just how much thought goes into how you're preparing all these videos. And as I was watching some of your videos, and recently looking at your video on Galore, you get so quick to bring the value, showing, here's how the Laura low rank thing works, and here's the difference with the gradients. And I wouldn't say I know it as well as you do. I appreciate you throwing me that line with, I'm sure you understand it. But so I know that we're going to dive into some, deep learning topics, but I just, one more nugget I want to pick your brain about kind of the business of making these YouTube videos and how you organize it all is, I'm very curious about, like, this is a very selfish question as I find myself in this boat of, like the future of your YouTube channel as you're graduating your PhD. It sounds like, and I just love what you said about how you kind of find your creative kind of expression through this medium. That's something that I really, have felt strongly. So yeah, I'm just really curious, like, do you see yourself just always making YouTube videos, always drawn back to this particular medium of like expressing what you're working on?
At the moment, yes. So, but I also didn't transition yet into the next step. And if you ask me this in maybe 6 months, maybe I'll change my opinion. I mean, you look at Yannick. He was saying after graduating, he will keep doing this, but now he's just so busy that he doesn't get to do it so often as before. So I think this reality might hit me as well. It's just that at the moment I draw such a positive impact from this that I cannot imagine at the moment myself stopping to do it. And it has been also a way to do something that I didn't think was possible for me. If you would tell me, if you would have told me 10 years ago, you will have a YouTube channel and thousands of people will be watching you, I would have laughed at this. Like, no way. I'm shy, I'm a perfectionist. I don't want to put myself out there because it's a little bit harsh that if you put yourself out there, of course, a lot of appreciation can come, but also a lot of criticism can come that you otherwise wouldn't have received because you didn't put yourself out there and people don't see what mistakes you do and so on. And especially for a perfectionist, that's really can be really harsh. And for me, it took like a lot of courage to do that. Just like upload my first video and put it out there and having views and having comments. And fortunately, like most of them have been positive. Of course, there's sometimes like this a little bit gratuitous negativity that also comes, but it's the internet, so you cover like a super wide range of like a whole huge distribution of people that can give positive or negative things. But it has been mostly positive, so that's been great. So it took a lot of courage to go out there for the first time. Then it took a courage to do this as a business, because at least in Germany, I don't know about in other countries it's much easier, but in Germany there's like a lot of bureaucracy and a lot of things you have to do in order to receive even €5 from somebody because they want to buy your coffee for the work you did. So something like Patreon was very difficult to it's very difficult to set up without having the proper legal preparations. So I opened a business with my partner on this, and then this was hard. Like in life, I was prepared a lot to like maths and do research and artificial intelligence and so on, but nobody taught me like how to do taxes, and I mean taxes in this way of a business. And he's taking most care of this, but also he was stressed by this because he's also a PhD student like me. And he was saying, "Wow, I'm dreaming of taxes at night because I'm so stressed that this could happen." And it was basically, it took this courage to set it up because it was a field of action where I wasn't trained in my life to do it. And it's funny that my supervisor, after I submitted my thesis, asked me, "Now that you wrote your thesis, is this the hardest thing you did in your life?" And I was like, no. Because for every PhD student, it kind of feels like the hardest thing to do is write up this thesis and hand it in. But for me, I felt like I was prepared years to write papers, to write abstracts, to write stuff about my research. So yes, it was hard, of course, and was one of my stressful periods in my life, especially because I had quite a tight deadline, and I was doing experiments for a new paper in the meantime as well. So it was like a lot of work, but I felt prepared, and even if I didn't know further, I could ask my supervisor, like, "Hey, how should I structure this chapter?" And at least some hints were coming. I mean, she wouldn't write the chapter, but she would kind of tell me a little bit, like, what would be a good approach. While for YouTube, who to ask? Especially, I mean, I could just ask Yannick, and he was very helpful in some aspects, but also he's doing his thing, I'm doing my thing. In different countries it's a little bit like you have to take everything with a grain of salt, and it doesn't apply directly. And yeah, figuring this all out, and like knowing how to discuss with sponsors and so on, this was all like I didn't feel prepared, and it was for me like a leap of doing something that and taking courage that I would say has made me a better person, like a better person prepared for what's coming next in life. So yeah, I hope that I will continue this, especially because it has helped me so much.
That was amazing. I was so inspired by that. Yeah, wow. I guess, yeah, definitely the courage thing. I really resonated. Like thinking about, yeah, you get a lot of negative. I do. I hope you get less. Sometimes I'll check YouTube and I'll have a notification. I'll just be like, well, I guess when you start, these comments really kind of hurt you a lot, but then as you go
Yeah.
on, you just
Yeah, you understand not to take it too hard, and but it comes with pro and cons, because at the beginning a positive comment was like, oh, it made my day, it was amazing, and a negative comment could ruin my day. Now I know how to take negative comments, and it doesn't ruin my day anymore, but a positive comment has also decreased in effect. So yeah, it's all a matter of getting used to it. And in the beginning, like, I was counting every subscriber, and I was like, yes, I have 42. Yeah. And now when you're in the 43,000s kind of area, you're like, yeah, cool, a new one. I mean, you're happy for it, but you're not like doing a celebration anymore for every single one.
yeah. I remember
But
like before. Oh, sorry.
how was it for you? Like, did you have a hard time setting up a business in your country? You're from the US, right?
Yeah, so I at I guess I don't really have too many like funny stories about that. I had just kind of set up an LLC
Oh,
in Delaware, and I guess maybe my only funny story is that I forgot that you have to pay an annual tax to an
uh-huh.
LLC. So then I had the bill for the 3 years of the LLC. But
I have a
yeah,
super funny story about this, because it was the German tax system is not necessarily super prepared with all these new media, yeah, and they knew about YouTube, and I was like, wow, crazy, they know about YouTube, and they could help out with that. And then I was saying, look, I also receive money through Patreon. What is Patreon? Yeah, well, it's a website where somebody just likes you, or knows you from YouTube, for example, and gives you money. Okay. And they were like, yeah, but what is it? How's it? How? Because I was asking them in which tax form number, under which number should I enter this Patreon sum? And they were like, I didn't know. They didn't know. And then I was searching myself on the internet, and and I found somebody saying, I mean, tax wise, Patreon is kind of like OnlyFans. And then I said that to the tax authority, and they were like, ah, OnlyFans, no. And then I felt a little bit, I didn't feel good, I have to say, yeah. But so tax wise, it's kind of the same. And then when you think about it, yeah, it is. I mean, whether somebody likes you for AI or other reasons, if they give you money, it's in the same under the same number in the tax form.
yeah, that's a great story. I guess, yeah, but I guess maybe the other thing of the business then is, is the sponsorships, and then like what kind of business you're trying to build out of your YouTube channel. And not like, I'm not trying to say like you particularly. I mean like anyone with a YouTube channel. And I guess kind of something that I did that I kind of think you do as well is that. So I renamed my channel from Henry AI Labs to just Connor Shorten. And
Yeah.
now I sort of think about it more as like personal branding, and yours is AI Coffee Break with Letitia. And
Mhm.
yeah, because I guess I think about uh, like, do I want to try to build out something like O'Reilly? Like I'm trying to build like a content business, or
Mhm.
maybe it's like I actually started it like delusional enough to think that I was gonna like build like
Mhm.
an open AI deep mind, and that was like young Connor's idea. But or you can kind of
Yeah,
use it. Yeah,
it's all a matter of scaling. Like, if you already start hiring a second person that does videos on your channel, then it makes sense to have something like an O'Reilly or a Henry I Labs. But if it's yourself and it's your hobbies, and you talk just about the things you find interesting, then I think it's good to keep it personal. Yeah, but keep in mind that anytime there's something like a shitstorm going on the because of the channel is then attached to your name, And because I know like Yannick has experienced cancel culture many times already, and that's attached to his name. And yeah, it's a thing that you should be comfortable living with.
Yeah, that's I guess that's another huge one is like even with the podcast, sometimes I'm so worried about like what I'm saying, opinions on other companies. Like if it's like Weaviate has all these partners with like say LangChain or Llama Index, and so it's like I'm never trying to say anything, like offensive or something like that. But yeah, really
Yeah,
interesting.
so that's one of my guiding ideas, because I sometimes find topics that are discussed in the AI research in the community on Twitter. You just have to open Twitter, grab a bag of popcorn, and you're set for the evening because there's so much beef going on. And I could cover that on my channel, and I could discuss that, but I was thinking, do I want to be that kind of channel that creates only things where it's drama or for the drama and polarize? And I was like, no, what I find most interesting and also safer to sleep at night is to have the just research and ideas. And of course, even there you can discuss like a lot. You just, if you don't like LoRa and you think it's a low rank, it's too low rank and you should go with a large GPU and full matrices, okay. But because even there I found it's sometimes surprising how polarized people can get. But it's not as in the some discussions that one can pick up from Twitter and go and discuss on YouTube that I think just already have enough attention, so it's fine. I don't have to talk about that.
Yeah, it's like if you're measuring your success on views and subscribers alone, probably I would recommend the best advice is to just cover the new language model.
Yeah,
And I'm a little
yeah,
guilty of
yeah.
that. I've done a couple of those lately, but that's like the easiest story to tell.
Yeah, but you know what I think, and because people often complain about clickbaity thumbnails or clickbaity titles, and I agree. Like there are some things that are clickbait. For example, you can't believe what happens next. Yeah, I have no idea what happens next, so I want to click it. That's total clickbait, sure. But if you say stealing LLMs, and actually stealing LLMs from behind API is the title of the paper, I wouldn't say that's clickbait. You could say the paper kind of used a little bit of a clickbait because, oh, what is stealing? And then people were arguing about the definition of stealing a little bit because if you is it stealing when you copy the data that is from is under behind an API, or the way the data in this way is the weights? I mean, I should say yes. Of course, the person OpenAI still has the weights, but I have the weights too, and I can create a lot of losses to OpenAI. So I think that's stealing. But there was somebody very opinionated in the commentary section who thought it's not. And I mean, sure. I mean, if you understand the word like stealing is, I take something from your pocket and it's not in your pocket anymore, then you say it's clickbait. But even if it's clickbait, so let's say it's clickbait, it's especially in educational content, if you don't clickbait too much, it is a good trick to like to trick somebody into coming to your content and choosing your educational content with a lot of matrices and linear algebra above fail videos with cute cats and people falling over, because that's what you compete with on YouTube. And the latest drama with whatever, the Queen and King of England is great. So you have to catch people, and then you trick them into educating them. And I think that's not like the worst use of clickbait ever. So even if stealing might be a clickbait, sure, I think it's a good use of it. And these people, when they wrote the paper, that was red teaming. So basically they saw a flaw behind the whole idea of APIs, that if APIs give also logit outputs and not even logit outputs over the entire vocabulary, just for K tokens, maybe 5 or 10, then that is a security risk, because it can really leak the last classification layers weights to an attacker. I mean, that's red teaming. And if you find a flaw, you want people to draw their attention onto it and fix it. So that's actually a good way to not let everybody have like the people could have chosen to leave this security issue just like how it is, and not fix it. But you want people to fix it, so it's good to make it at least a little bit catchy and a little bit like, oh, it sounds perilous, so let's do it. So that's what I think about clickbait. And when you're talking about let's cover LLMs and let's cover the latest cool stuff. Yes, I mean, it's okay to do 2-3 videos in some weeks about that. Then you get a lot of clicks, you get a lot of people finding out about your channel. And after that, you can do a video about not LLMs and about another cool thing, and you basically trick them into educating them about that as well. Because otherwise, if it were not for the cool LLM papers, they wouldn't have known about your channel either. So I have kind of this. I mean, I can see it in my stats. I have videos about like popular things like Mamba, and then it's super many views, and then I have Shapley values, and it's not so many views. And I think, why not?
Yeah, I remember I had done like it was like neuroevolution of augmenting topologies, like a neural architecture search paper, and I was so proud of it. I was like, this is one of the hardest papers I've had to study, and then no views, no one cares.
Yeah, nobody cared. Yeah, and people. So how I see that people come to my channel is by actually searching for a paper title themselves. So basically, they search LoRa on Google, and then my video comes. But what the premise is for this action is that people have to search for that topic already, and nobody would have searched for the topic you just described, and that's a little bit of a loss. You have to that's why you have to sometimes cover like popular topics that people search for. They go into your channel, they find your channel, and then they see, oh, there's this super weird topic that nobody cares of, but I will look into this. And basically what the result of this is that you have excited somebody about your thing, but by having them by having delivered to them an explanation about the thing they were after in the first place. Yeah, so that's kind of the art of in education, to get somebody to listen to you in the first place, because you compete with cat videos and the Kardashians and many other things.
Yeah, I guess that kind of inspires me thinking about like the catalog that you're building with your YouTube channel and all this kind of thing. But I thought this was such a great coverage of the, making YouTube videos and building YouTube channels. But I really want to pivot into, unpacking all the insights you have on AI and deep learning, and maybe kind of as an opening question, and then we'll sort of zoom in into particular topics, is just broadly, how would you say kind of the conversation around AI and deep learning has changed over, say, the last 2 to 3 years?
Yeah. I mean, if you think about it, it didn't change that much. As people, like, there are, of course, a lot of changes. I was writing my chapter in my PhD thesis where I was making a little bit of a review of how just the transformer architecture was coming to be, or what even was behind before transformer architectures. When I started with my PhD thesis, which was on multimodal models, so models that combine image and text and understand image and text at the same time. You can have this with GPT-4o nowadays, or GPT-4v, or Gemini, and so on. It was CNNs for the image, an LSTM for the text, and the CNN was producing an image vector, a representation of the image. The LSTM was cramming a sentence into just one vector, and you had these two vectors. You either concatenated them or element-wise multiplied them, and then you did something with that. For example, try to classify which answer from the possible answers is it from the data set. And so that was where I started, and then a whole paradigm shift came. Namely, people introduced transformers for this, and it was funny. I was basically reviewing a paper where the authors were saying that transformers came for text first, which is true. Like we have attention is all you need is on machine translation, so it's text. Then they said it came for vision and like just images, and then it came for multimodality. But it was because I lived it and I saw it. It was not how it was. It was first for text, then it was for multimodality already 2019. 2019 exactly. And then 2021 it was the VIT that was doing it for images. So people have realized that you can do this with multimodality with transformers way before they figured out how to do it better than CNNs with images. I mean, people could do images with transformers before, but I think nobody published a paper with this because ResNets and everything else were just way better. So yeah, I mean, they basically got this wrong in the paper and mixed it up because I think they weren't there to follow it, and I was there to follow it. And it feels like when you're looking at the methods you're using, first it was CNNs and LSTMs, now it's transformers. But if you think about it, it's not that much that has changed, because what it was all about before was having deep learning models, which is basically the paradigm of you have no idea how to compute representations, so you learn them by gradient descent. And LSTMs were super slow, therefore, because they iteratively, token after token, have to compute, like to process the sentence, while transformers can do it in parallel. So you didn't achieve a ChatGPT with LSTMs just because it took forever to even parse Wikipedia, and something like the whole internet wasn't feasible. And then with transformers, because just they're faster, it was feasible. But I don't think that they're any like better, other than like speed and the ability to just eat a lot more data than the other one. So it's always this. It's about neural networks, and encoders were very popular for transformers for a while. And now, like, what has changed is that we have decoders that are really popular, and decoders became popular for text. Then they became very popular for multimodality. And it's kind of easy to understand that you have an LLM that already processes text very well, and if you wanted to process images too, you take the image, you represent it somehow as a vector, and you have a lot of freedom how to do that. You could just take rows of the image and write them as vectors, but it's a little bit inefficient because you can have many such rows. Therefore, you take patches and linearly transform them into a smaller vector. And then you have this information and you put it into the LLM. Just that these LLMs do not understand image vectors, because it's like, what is this information? I don't know what it is. So you can tune a backbone, a visual backbone, that translates these image tokens into the vector space of text that the LLM is understanding anyway. And then you basically can have this LLM also understand the image vectors that have been translated to text vectors. So, and that has changed. So now we use these decoders, and like, you use different methods, but in the end it's still representations that in the end you do something with. What has maybe changed for the user and not for the implementer a lot is that you have now these LLMs, that you have these models that for multimodality or just for text only produce the next word, is that you have now the impression that they can talk to you. And sure, I mean, in the previous times where you had an encoder, you had like an encoder produce a representation of a whole sentence or an image, but then it did only classification. So you had to ask it, is it something, yes, no, and you had binary classification of yes, no, and that wasn't really verbose and wasn't really producing this language that we're using and I'm using right now to convey so much information that is in my head. And now, because they can, these decoders produce this text, it's really this language of humans. And when humans read this language, they even start putting their own knowledge onto it. And even though the LLM might have said something vague or out of context, you might get it just because you have the context and you have the understanding. And with RLHF and with instruction tuning and so on, we have just made these LLMs more probable to produce the things that we expect them, and not just produce anything that, because if you don't do RLHF, if you have a language model, you ask it, what is Einstein known for? And plausible continuation is what is Niels Bohr known for? Because after you did a question, it's plausible to just ask another question, right? But you don't want that. That's not something that is a good conversational model. So you RLHF tune it into answering the question, or instruction tune it to that. So now it has got this power to talk about things and produce this language that is so intrinsic to us, and like, we humans proud ourselves on having it. And and then a lot of things start to happen. For example, this LLM might say, you are ugly. Yeah. And you're like, oh, you're offended, right? But you know what, the LLM never saw you. Yeah. So this offense is really in the eye of the beholder, right? And because what is the problem with language, and why can you offend with language so easily? because it's really bears a lot of meaning. It has also ambiguity, and it's very context dependent, because maybe there is a culture out there in another galaxy where being called ugly is a compliment, right? Because maybe that's the standard, to be the ugliest being in the universe, right? So this is the problem that we and like people call and cry about AGI, but the problem I see rather is that these LLMs that produce language now have the the problem that they can offend and they can persuade and manipulate. Right? Elections are coming, and it's actually in the eye of the beholder a lot. But if a person that is malicious uses that it knows that, if I have this LLM that will talk a lot about that politician and a lot of bad things about another politician, can manipulate people, this has a lot of impact. So the impact onto society is basically that's what happened, that these models are now able to verbalize not necessarily what is in them or talk very well about what they do, but they're able very well to mimic what we expect them to do, because that's what our chef is doing. And for example, I found, like, my last bit of my PhD thesis, my last chapter was about the question of faithfulness of language models when they talk about their reason of why they said something. Like, I asked them, how am I looking today? And they say nice. And I was like, okay, but why am I looking nice? And then they have to deliver a reason. And the problem is that, and what I found is that they really like to talk a lot that um, that you expect. Like, I expect to talk they to talk about something and something, but it will not talk about actually the features that it found more useful when delivering the answer. So they're kind of unfaithful. Yeah. So maybe I think that's what people would be very interested in, to make them not produce whatever, but produce something that really reflects the internals.
Amazing. And first of all, I want to compliment how you context switch from talking about YouTube into the whole end to end, from architectures to how we were evaluating them, and all this is really remarkable. And so yeah, I think maybe if we could just kind of keep flowing from here into kind of zooming in on particular topics of deep learning, and then maybe trying to return to this theme of how it's changing. And yeah, model architectures is one of the topics that we have kind of selected ahead of time. And so if we could just kind of now come into data sets and tasks. I think what you're saying about, we used to have classifiers, or say, extractive question answering or named entity recognition, where it was super easy to say 88% accurate, or even with class imbalance, you could say, 88% on this class, but 73% on this class. But now we have like retrieval augmented generation systems and agents where they give you long text, and it's just really difficult to evaluate them. And that's maybe one of the most pressing topics that I'm seeing. So yeah, if you could just tell me kind of how do you feel about like data sets and tasks, and sort of how that's evolved?
Yeah, interestingly, because the generation, the evaluation of natural language generation is again something that actually didn't change. This has been a long-standing issue since machine translation first occurred, and people were evaluating this with BLEU, so like really looking at whether n-grams overlap exactly, and that's not maybe the best option. And then they have tried to come up with better metrics, but it's really, really hard, because to know whether something is translated well, or whether I really answered your question, you have to understand my question and have this really semantic understanding of what's being said, because you can say one thing in so many ways. Yeah, and this hasn't changed. Like, this is an unsolved problem, and was an unsolved problem. It's just that maybe at the moment we even have a better attempt at doing it, because we can use the fact that these language models, when they have to generate something, it's kind of a hard task to produce the right word after the right word after the right word. It's hard, but it's easier for them if we give them a question and an answer and let them evaluate, let them say, is this right or is this wrong? So let's say a language model has produced an answer, we have no idea whether it's good. We take maybe the same language model or another language model to look at this answer and the question and judge whether it's good or not. So in that regard, natural language generation has made a leap, because people have shown that in numerous evaluations, in numerous papers, that they use GPT-4 or whatever language model as an evaluator quite successfully, because humans tend to be wrong, kind of the same, or annotators tend to disagree among each other as many times as the annotators disagree with ChatGPT. So ChatGPT is kind of like an extra annotator that doesn't cost so much to use as annotation tool. Yeah, but this I mean, this is great that you can use that, but it's also a bottleneck, because I was trying to use that in my last paper as like a language model evaluate whether two answers really mean the same. And it was really hard, because it was basically a visual question answering system where it was saying, like the question was, where is the horse standing? And one model said it's standing on the sidewalk, and another model said it's standing at the corner of a street. And when you looked at the image, it was actually both correct, because this sidewalk it was at the corner of the street, so they were both correct. And to prompt a language model to know when this is correct and that some other almost synonyms are wrong, it's very hard. It's very difficult, especially without image understanding. And image understanding is not at that level so far. So I would say just language understanding is a little bit easier to do. So it was a little bit useless, but it's better than nothing if you think about it. And also, so it's a problem where you have this, like, really where semantics matter like a really lot. But there are also a lot of tasks where I think that now it's being made a lot of progress on, where it's actually kind of easy to verify whether answer is correct or not. And this is the case of mathematics. Like, you say, give me all pairs of A, B, C, D, where A to the A square plus B square equals C square plus D square. And then, I mean, if the model gives you A, B, C, D, you just put them into the equation and find out whether that holds. And there was this work from, I made a video about it, but I forgot from where it was. Maybe DeepMind or something like that, where DeepMind. It must be DeepMind, because that's where they're doing usually science. They were advancing a problem in mathematics that had been long standing, when people like mathematicians didn't have any good ideas for many decades, with just an LLM producing like proposing solutions, like proposing pairs for A, B, C, D, which not for this problem but for another problem. And of course, in the beginning, the solutions were stupid and not exactly like, if the mathematicians don't know, an LLM wouldn't know either. But if like, you can check it very easily whether that's correct. And then they took whether that's at least close to what you want, and then they took the best answers and prompted the next question for the LLM with those answers. And they basically had this evolutionary strategy of choosing the right answers and starting from them, and to produce even better answers. And in the end, they produced basically a Python program that was implementing the algorithm that was the solution to the long-standing problem in mathematics. So in I think in sciences, where you have this right and wrong, in chemistry, where something can like either work and be stable or not, or in mathematics, where things are right or wrong, we will see like a lot of gains from LLMs, because they can produce a lot of garbage, and you chain of thought prompt them into everything, and from a million generations that they do, you can select the good ones. And yeah, it's basically a generative feedback loop, if you think about it. You produce a lot of things from the LLM, and then you store maybe everything, or not everything, but just the best things. And from these best things, you can search through them and put the right things inside into the model again, and produce better generations, and then store again, and so on. So you have this loop, and it can be self-improving. And I think that's what we will see way more in the future.
Yeah, it sounds kind of like that agent architecture type of thing, and yeah, generative feedback loops. Obviously, we love that phrase at Weaviate, and yeah, I really like the kind of when you can verify if it's correct and how much easier that makes it, and that really draws me to wanting to work more with the like the coding systems, because I think about like a task at Weaviate might be, hey, we need to improve filtered, approximate nearest neighbor search. Can we change the HNSW algorithm in any way? And it seems really reasonable that it could be hooked up to a database of all the papers that have discussed this, and then it could, make changes in the Golang code, and then it can test it and see the speed, and maybe also see other dimensions, like maybe it allocated too much memory or it took down the time
Yeah.
to index. Yeah, and
Yeah,
yeah,
yeah, I think that's a totally like a great idea because DeepMind has shown this with search algorithms in C++ already because that's what basically they could measure. Like they let the LLM write an algorithm for sorting, and it was you can actually measure. You can run it and see how much memory it consumes and whether it really does sorting. And then you can take the best programs and edit them and have even better programs that are sorting even better because at the beginning they're not really sorting and use less memory. And that's exactly what you could use to optimize that, like your k-nearest neighbor search and so on. You can just write a more efficient algorithm. And also there, I mean, for decades people didn't come up with faster things, and now the LLM just did, which is amazing.
Yeah, but then there's this other dimension that I'm really curious about, and I think it comes into our next topic of the new learning algorithms, is when it is more abstract, like you discussed, like the what is sorry, I've forgotten it. I think it's what did Albert Einstein do, and then it's like, well, what did another scientist do? But
Yeah, Niels
like,
Bohr. Yeah. Yeah.
yeah, so compared to this kind of like preference optimization, where it's just like the evaluation criterion is way more open ended. It's like people currently use these ELO ratings of LLMs where they talk to each other, and a third LLM says, this one was smarter, and so now it's like with an answer to the question, you could come up with I think like something that Perplexity does is they evaluate it on how succinct it is. Like if I ask you what is product quantization, you just tell me how it works compared to like big answer of how it works, but then it's like which one is more detailed, all sorts of dimensions to it. So maybe if we could kind of come into this evolution from supervised fine tuning, and that's something that I think could work with a feedback loop pretty straightforwardly with like the code executors or the proof verifiers, where you have this ground truth of did it succeed at the sorting algorithm, compared to maybe like this like where we have direct preference optimization and we have this sort of reward model that's now in the picture. How have maybe like these learning algorithms sort of been developing to handle these cases where evaluation is so difficult and we have a more abstract notion of what's better than another thing?
Yeah, so I don't know what you said makes me think of DSPy a lot. Like, yeah, it's so basically what the idea there is that you can do like a lot of optimization on top of LLMs and their outputs, and quite easily because what they have quite this ingenious way of implementing that. They like in PyTorch, you have layers, and then you say I do a matrix multiplication and nonlinearity now. And in DSPy, you say I do now, and I let an LLM produce a question, an answer from a question, and then the next step is to take this answer and do something with it, and so on. And you do as many LLM operations you want, and in the end, you can give it a few examples and have it optimize prompts as to increase the score on those few examples. So what basically happens there is that you like in PyTorch you have these matrices and these weights of matrices in that capture weights that you optimize, and there in DSPy you optimize prompts that will in turn produce better outputs from the LLMs. But these outputs from the LLMs are a little bit like the activations in PyTorch. And so when you think about it, in PyTorch you have vectors, in DSPy you have text, you have language. And the great thing about it is that you can read that as a human, and you can like store it in a database and search through it and see what's in there. And that's a great thing. But the downside of it is that sometimes, as a human, you're too busy to read everything that was produced there as a text, and that's maybe even better to have efficient search on it, and then search just for or to cluster something to see whether what was there very prevalent. And yeah, I think the what's interesting about DSPy is that also it uses like LLMs to do this optimization process of prompts. And you could think, well, you're using LLMs, which are not the end result of AI research, right? Because we will have a better LLM tomorrow, hopefully. or but you're having like a limited system bootstrap another system or another equivalent almost LLM, then you have this imperfect thing give feedback to another imperfect thing to make it more perfect, and you're asking, how does this even work? Well, the cool thing about this is that you can do it as many times as it's necessary, and as long as you're moving at least a little bit into a better and a better direction, this optimizer LLM can have 1,000 stupid suggestions. If one of the suggestions is gold, then basically you solve the problem. So yeah, that's actually like optimization in language space that happens with all these models. And as long as you have a few examples of right answers to some questions, you have kind of a loss function, and then you're optimizing it. And what's even in because and that's a thing that kind of changed, but it's again a thing that didn't change. Like before, we had optimization in vector space, now we have optimization in language space, but it's still optimization and trying things out until you find the correct things, like the correct configuration that gives you the right answers. And if you have a few examples, it's kind of few shot. But if you have a lot of examples, that's many shot. And with these large language models with large context windows like Gemini, you can fit a lot of examples. And it's becoming interesting that fine-tuning and few-shot learning are now moving a little bit again into many-shot and supervised fine-tuning, because you use so many examples that you kind of train on ImageNet again, like on a million examples. It's yeah, so history is repeating, just at another level of abstraction. We're not programming in code anymore, and we're programming with code, but we're not programming in this vector space anymore. We're programming in language space.
Yeah, I couldn't agree with that more. And that's one of the things about DSPy that just fascinates me, is this abstraction over, like a learning algorithm used to mean gradient descent. Certainly you're updating the weights, but now it means like maybe you're tweaking the prompt or you're producing examples of the task. And then, yeah, I love that scale of you're producing tons of examples for many shot in context learning. And now you have, let's say, 1,000 examples. It's like, well, should you fine tune a model? And it's maybe like smaller and cheaper. And then there's this whole question around, okay, what's the tooling for then that fine tuning? Like we love OLlama at Weaviate and how they can, wrap around Llama CPP and help you with these Docker deployments and all kinds of things like that. And that's definitely something that's cooking up. But I guess kind of one question I really want to dig in further is kind of like what might lead to like super AI, right? Like maybe not like AGI where it covers like a really diverse range of topics, but just like if I'm building a chatbot that talks to me about Weaviate blogs and I want it to be super smart at it, I'm not even really sure how to pose that question myself, but I'm curious, like if these new reinforcement learning algorithms like say ORPO and all the derivatives of DPO and how they like use gradient descent to maybe get a super smart neural network, if that would be more powerful than maybe example tuning with super capable general language models, and just how you currently see that.
Yeah, so well, I think that with a careful tuning with some like a few examples, you can get so far. Like if because you're not tuning the LLM so much, and if the LLM just doesn't know about a concept of reality, it's really hard to make it get it. And maybe it gets it in a very particular use case, like it understands of a new person, but it is very hard to make it introduce that new concept and person into all of its connections that it has about so many facts in the world. And we have seen that in not exactly fine-tuning, but in model editing. Like model editing techniques, they basically try to make a model not think that the Eiffel Tower is in Paris anymore, and it has moved to some other place in Rome. And what they do is they go into the model and find the representation of the Eiffel Tower and of Paris, and they change it exactly such that it's not in Paris anymore, but it's in Rome. But what becomes it's absolutely like not possible so far, at least not to the perfect extent, to then also move other landmarks from the close the or in the Eiffel Tower also to Rome. Like the restaurant that you have on this floor, it doesn't move to Rome as well, even though the Eiffel Tower moved. And or it's becoming even more complex if you have like a person and you move a person. It's not the president of the USA anymore. You make the model believe it's the president of another country. Then of course also the wife of that president must move as well, but it's not happening. So model editing and making like updating a model such that like a whole, like its all representation and all its internal facts make it such that the new fact that you have learned through a few example accommodates. It's I think very, very hard. And like to make really smart AI, you need that as well. Like you need any AI that we have, it has to be few shot promptable. It has to react to better prompts and better framing the question. Because even so now, for example, prompt engineering is a little bit criticized because it's silly, right? You say give me a list of all formulas that Einstein is famous for, and the model might be lazy and just doesn't give them all. But then you say, please, 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 I will buy you a beer if you do that. Then it will produce it, and it's a little bit silly. But in even when this silliness might be overcome and then the model will really understand us better, it's never going to understand it just from text and inputs with a keyboard or with voice so well that it really knows what we mean. Because even you, if I tell you something which is in my head really nice in context, but in your context it's not there, I need to really explain things. I really need to provide it context. Therefore, this RAG thing will be, I think, always helpful, because RAG means provide more context, right? RAG means I was lazy writing or specifying something that I want, and it will provide this additional context such that this smart LLM will know what to do. But in order to and RLHF and maybe DPO, or these things will always be necessary to really make the model talk about the things that we find interesting in as humans, sure. But I think to really have this even better LLMs, like even better AI that is moving on from today's AI, is maybe use the concepts that have been used in AlphaGo of self-play. And this, I mean, it's not exactly self-play that is happening in DSPy, because in DSPy you have another model that tries to fix another model's prompt. So you have models helping models. It's not adversarial in this way. It's not like models trying to outcompete other models. But if you want to train an LLM and you have seen all the data you can, because it's the internet and you don't have more data than the entire internet, and want to make it even better, maybe the idea is to train it with a copy of itself, to try to have conversations with itself, try to convince each other in conversations of something, and provide help to each other, such that they together can become smarter. Maybe that's like the missing component.
Yeah, I think definitely that this whole like multi-agent system, and then I guess maybe I even want to keep on this beginning part of the model editing and how you would update knowledge in models. And we had looked into things like Mehmet, Rome, and Grace, and this like
Exactly.
and this fact dependency that you mentioned, where you say, okay, LeBron James, he never played for the Cavaliers anymore, but then you're like, well, who was Kyrie Irving's teammates when they won the championship? And then it's like you have to invert all these fact dependencies, and it seems pretty untenable. Whereas I guess like thinking with RAG, it's like maybe the perspective should, just listening to you, I was changing my own perspective of what instruction tuning might mean. Whereas usually we're saying like, please re-rank these documents compared to like please order these documents better based on semantic, like it's like little tweaks to the language is usually what we think about prompt engineering. Whereas maybe instead it could mean like forming really big prompts of background knowledge
Yeah.
that kind of helps you get it up to speed. But I guess I don't even know if what I'm saying is like well formed, but I guess it's like, can you learn like I guess the language models with the weights that they've already learned from RLHF, and then their pre-training is like they have like this like reasoning ability that's like really esoteric and hard to pin down, but it's like, do they already contain all of the reasoning ability they need out of the box to just have the right context and then they're all set? Or maybe by additional gradient descent throughout doing the task, they maybe have like in their parameters like a new way to reason about concepts, and it could be grounded for a particular context.
Yeah, it would be great if during fine tuning or updates, a new algorithm might emerge. But I'm always a little bit skeptical of that, or how many examples you need, or how to fine tune such that you get a new algorithm, but you don't forget the other algorithms. So
Yeah.
that's the hard thing, that like to really understand, like make a model, get an algorithm. As far as I know, you need a little bit more examples to like fine tune a model such that it's good of a specific thing because it has this shallow reasoning and a lot of memorization. I think that's easier, but to really make it get the algorithm, that's really hard. And there was research in mechanistic interpretability where they tried to do like modulo division, or like something that you have an algorithm for, but the model was, because it's always limited training data after all, it had a very hard time to really learn the right algorithm, and it found an approximation with cosines and sines, and like a super like a Fourier decomposition looking thing for doing this otherwise simple algorithm. But it's usually very hard to like make a neural network with all these dense layers really model simple algorithms. A simple test is just initialize a network, like a feed-forward, like a just a fully connected neural network, and try make it like learn the rotation matrix of something. It's usually not exact. It doesn't learn what we think of as a rotation matrix, because we initialize it with random values, and to make these random values really have this structured form with SGD, it's very, very, very hard. And it will learn something that will do this rotation operation on the training data, but not really on the test data. And it will you have this problem of overfitting basically. And it's interesting that there's this grokking research that has found that you let the model like to learn this, it doesn't succeed yet, and you forget your training run on the GPU on for the night, and after training way longer than you would have usually trained because you would have done early stopping, it's basically totally an overfitting regime, but it's training. And after a while, the training loss will be zero because it was before, but also the validation loss will decrease to zero as well. So the model has learned that the right algorithm. And so this is for toy data. So for letting the model learn on toy data, the right algorithm, you have to basically not train for 3 minutes like you have like usually train, but for an entire night. Therefore, to do that for ChatGPT, it would mean that you don't train for 3 months, you train for 4 years or something, or even more. And I think that's not exactly feasible. So yeah, when it comes to real understanding and like making a network learn the right algorithm, I'm usually very skeptical, and that it can be done with like very few examples.
Yeah, I'd say that grokking paper was the most like, okay, I don't understand anything when it came out. I do work, like kind of something that my PhD took me into was studying robustness and generalization testing, and I was just kind of testing CFAR 10, and then I would rotate the images, and all of a sudden it would go from like 95% to 70%, and that was kind of disheartening for me. And I was recently playing with the Bootstrap fine tune in DSPy, where you're trying to fine tune T5 large, which is 700 million parameters on, I play with this data set of Weaviate blog FAQs. And I can't imagine that it's going to be as robust to a question it hasn't seen before or variances in the questions. So I guess right now I'd say I'm still pretty skeptical on the on the train your own model. I think people are very excited about it because it has this promise of being cheaper and faster. And then as we talk about all these like agent chains where it's going to evaluate itself and maybe reapply itself if it's not a higher enough quality. I think that's
Yeah,
what
but
draws.
even there, you're in the trouble of fine tuning on these few examples of evaluation that you have. And yeah, when we talk about generalization, I'm not only skeptical about fine tuning, but actually even of this whole pre-training, because people are so impressed with, oh, ChatGPT is so smart, it can do that, it can do that, it can do that. And the thing is that it's like, wow, it's very improbable that it has seen this question, so it's definitely generalization. And I don't think that's necessarily the right thinking about it, because in a sense, like I or everybody, any human has trouble imagining what's all written out there on the internet, because I visited a little tiny fraction of a percent of the entire internet. It has visited kind of almost all of it, and I cannot imagine even what you might write in your free time. And of course I cannot imagine what 7 billion people will write in their free time. So it's like an enormous amount of data that it has seen, and it's for us very, very hard to know whether something wasn't, at least in some combination of similar things, already out there. Then there is this paper from Princeton from I don't know if I get the name of the senior author right. Yeah, not at the moment, but where basically they have this argument that there is generalization happening in neural models, because the number of skills that you need to solve a new example is very high, and it's combined from other skills that you maybe have learned on the training data. So on the training data, you learn skill A, skill B, skill C in independence, and then to solve another test example, you need to combine skill B and C, but you have never seen skill B and C together in one example in the training data. And I believe that the number of possibilities to combine skills is like exponentially big, and like even maybe factorially big, because it's like combinatorics. And it's overwhelming. And I do agree that the model has to combine existing skills to solve test data. But I'm not that when I think of generalization, I don't think of combination of already existing skills, but of really like coming up with a new skill. And that's something that cannot I don't think is the case. And therefore, when we say, "Oh, ChatGPT is so smart," yes, it has been. It's so smart because nothing is out of distribution, or no skill is out of distribution. If everything, the whole world, is the distribution of the model. So just increasing training data by like to the whole world is maybe the way in which we can have this robustness, but it's not actual robustness. It's just really training. And having seen like you will be not surprised by any exam question if you have solved all possible exam questions in this world. Yeah.
Yeah, I love that kind of thing. Like the compositional generalization. I almost like how smart the word sounds. It's like part of why I think mechanistic interpretability is so popular. Like, what do you work on, right? You sound smart, and I'd always wanted to study that with like cats, dogs, wearing a hat, not wearing a hat, sunglasses, not sunglasses, and yeah, the combinatorics of all these different things. And what you say about all the skills in ChatGPT being yeah, I mean, just thinking about pre-training all of the internet is like such an absurd scale, and I don't even think we can really understand that too well. Awesome. So kind of one other question I really wanted to zone in on is, earlier we were talking about the evolution of attention versus convolutional networks, and say like the early days of the vision transformer, you had this like patches thing, and so people were like, I don't really think attention is going to work with images. And I see now you have an awesome video on Mamba and state space models, and So I'd love to get your take on, is there any chance that the transformer is sort of disrupted by one of these other models? A mixture of experts is definitely kind of making that argument. Yeah.
Mhm. Yeah, so I think that Mamba is the closest competitor to transformers that we have seen since the emergence of transformers. So it's really great, and it's really like a reason to be excited about, and I think it's also a reason to learn about it and also try it out on your own experiments. But there's this thing that so what is Mamba? It's actually a linear RNN if you think about it, and it's the most boring and stupid RNN you can think about. But also, like, you have a linear RNN and with a lot of other non-linear layers around it, and then you have this Mamba layer. But it is a linear RNN that is taking care of merging into the current token what was in the previous token and the previous token, so because it's recurrent. Yeah, so with state space models or XLSTMs or with all these kinds of making RNNs fit for the transformer era papers, they have the problem that they have to cram the whole context into to condense information into this memory vector, and from it use the information. And there's a lot of information you can capture in 1024 dimensions, because there was this like Raymond Mooney is famous for saying you cannot cram the meaning into one F vector, but actually you can. If it's 1024 dimensional, you can express a lot of sentences and meanings with 1024 dimensions, and even of course more. But after a while you have the limit of you can only memorize the things you have decided in training to memorize, and some things you forget. And then if you want to do the needle in the haystack test with Mamba and these kinds of RNNs for transformers era, you have the problem that you don't have this 100% recall or even 99% recall that people have shown with transformers. Because when you look at Gemini, they were very proud of having this like super high needle in the haystack recall accuracy, and it's something that I don't think you can do very well with Mamba or like with state space models or linear RNNs. So if you want this combination of high retrieval, like needle in the haystack, and this efficiency of linear RNNs, then you need to combine them in hybrid architectures. And now there's this push of hybrid architectures that combine attention and this thing to. So the transformer is not like it's over, because it's the, like, attention is a way to always have the information to your hands, and you can use them, because you have just to attend to that and you get that thing that was said like many conversations ago. While in a linear RNN you have to have it in the vector, and you have to have decided to memorize it. Therefore, yeah, it's, I think for some applications it's not great, but for many applications like where you have modalities of very high dimensions like videos and RNA sequences and so on, I think if like the bottleneck is that you cannot fit your sequence into memory, Mamba is a great go. And if you don't care for this needle in the haystack test so much. And what is also a little bit misleading of needle in the haystack tests of where transformers are so great is that usually they give tests where you have to find one needle, two needles, three needles, but it gets also quickly worse when you're trying to find many needles where you hide too much in it. So yeah, it's maybe sometimes of a like a PR move that like Google and people that like have transformers for long sequences try to boast about, but it's not necessarily something that like a application would directly benefit of, if, especially if you want to find many needles. And about the Gemini paper that was this about the sequence length and had like a super a good performance in a needle in the haystack. It was, I think, for me very interesting to see that Google had this like they wanted to test whether the model can learn, like you can use this long context to make something new with the model, something like a generalization test that wasn't seen before. So they came up with this language, I think Calagan or something like that, and that is not written on the internet and spoken by very, very few people somewhere in this world. And they gave it, like they inputted, they typed in for Gemini this Calagan. I think I hope I'm pronouncing the name of the language correctly, but they typed in the dictionary of this language, and then they asked the model a question in that language, and it's absolutely zero probability that it has seen this language during training. And interestingly enough, the model could use that dictionary and then provide an answer in the same language. And it was really a cool generalization test where if you can fit a dictionary in the like in the working input of the model, you really get really cool things. Yeah. And then of course there were people on the internet saying, but why would you do that? Have you asked these people if that's necessary? But it was actually a scientific test of generalization and not really necessarily an idea for a product. So that was again a funny thing I could have covered on the channel to get some beef points, but I just
Yeah, that's been one of my biggest takeaways from our conversation, is being more interested in that like the dictionary style thing in the input, and thinking a little further about how we think about instruction tuning, and then how that differs from then the example in context learning, and all that. And so I just kind of one more question I had on the kind of model architecture thing is, we're very curious about like this RAG 2.0, as contextual AI calls it, where you have like retro or end-to-end generate and embedding models. And so I'm thinking about maybe like the representations could change, like the embedding model can change without needing to change the language model, maybe, like and you can just put these pre-computed embeddings in the architecture. I'm sort of going back now because I don't like I introduced this by saying like end to end, but I don't think necessarily you need to continue training the decoder part.
So you think a little bit of prefix tuning here, where you basically make, but in prefix tuning, you update the vector such that the LLM understands it, and you basically make the embedding model produce vectors that the LLM understands. Is that what you're after?
Sorry, I didn't set this up well, but that is really interesting stuff as well. As there's so many different cool topics. But I guess like one idea is that with retrieval augmented generation, instead of just putting the retrieved context directly in the input, you might put the pre-computed embeddings in, say, the representation at layer 8 out of 12. And so instead of transforming the key matrix with like a weight multiply, you could just stack these pre-computed embeddings and just like plug it into the attention computation. And it's kind of like what we've been saying with like pre-trained transformers as universal computation engines. And I think you mentioned earlier with like, how could a text transformer possibly reason over an image embedding space? But like they are able to do that, right? So this idea that you could,
but I think that you can reason on an image space if you translate this image space into the language that like in this space, in the text space that the model already understands. So yes, I think you could plug these vectors in, but you need to scale them, transform them to at least some learned linear transformation, such that it lands into a space where the model really can do something with. Yeah.
So that so there would need to still be some kind of adapter layer, but it sounds.
It can be lightweight. I don't think that would be like a bottleneck of anything. It's just like linear transformation. It might be necessary to train, because it was also interesting in image research. A lot of people were thinking of complicated backbones to represent the like to translate the image space into the text space. But what in the end came out is that even just a linear layer is enough if it's learned. Yeah. So
Yeah. Well, I think that one's super interesting. All this kind of talk about what you need to learn, sort of representations, and how you can adapt representations, and then thinking about this kind of the state space model, how it's got this like fixed memory. I find that to be very fascinating. Thinking about how maybe like a vector database can integrate learned representations with these kind of architectures, and all that kind of
absolutely
stuff.
Yeah.
Awesome. So I think we've already kind of covered DSPy a little bit. That I wanted to ask you about DSPy, but maybe if instead we could ask sort of a broad question of just kind of generally like what directions for the future of AI are exciting you the most?
I think, but I'm biased because that's basically what I worked on since I started my PhD thesis, namely, I think multimodality, because this problem of context. Yeah, so the model doesn't really know what I want it to do. I didn't like my prompt is incomplete. My prompt misses information. It means that like what we need to do is get more information for the model, and I see RAG a little bit like, of course, with a in a metaphorical sense, I see RAG as a way of doing multimodality, where you're not really employing information from a new modality, it's still text that you're providing, but it is this additional information, this additional context that you provide the model with. And multimodality is all about this. I have ChatGPT open and I ask it a question and I ask it, what should I wear? And it doesn't see me and it doesn't know I want to go or where I want to go. It doesn't know where I am. It doesn't know my situation. So multimodality is all about give it image input, give it also audio input, such that it even can understand from my tone whether I'm stressed about this event, whether I'm worried or I'm relaxed. So it's all about additional information, because in the end, when we have a model that has all this information, it is way more informed and of course understanding of that information, it is way more informed to do the exact prediction which I am expecting it to do. It has this context. Like I think of like future AIs of not being this ChatGPT that is on the browser. I'm seeing it a little bit like this AI that is sitting on my shoulder, in my necklace, or in my glasses, that sees what I see, has the information that I have, and if it does that, it doesn't need extra information because it already accessed it by itself. And that is a little bit rag for company internal data, right? Because like a model that was trained on the internet wasn't trained on the documents of my bank, right? But if we augment it with this modality of with this additional information of the bank internal documents, it will have this information. So like the future AI assistant will be I wouldn't say, I mean, people talk a lot about embodiment, but I think like a super helpful AI already would be a multimodal one that is on my body. So it sees what I see, and or maybe even a 360, has access to internet and has access to whatever information I am willing to give, and provides and it can help out a lot. But because then you don't need to prompt it as much. If like if it knows from the tone of your voice this is urgent, you don't need to prompt it, and don't need to speak the words, it is urgent, please help me. Yeah, so I think that's the direction I'm most excited about, and we see actually a lot of advancements with it, because I mean, OpenAI has this Omni model now, Gemini is multimodal, and people now are trying to do this. The challenge of multimodality, of course, is what is has always been, and this is again something that didn't change too much, namely, if you introduce additional information, be it RAG information or multimodal information, you increase the sequence length. If you cannot handle sequence length and really do something meaningful with it, it's already doomed to fail. The other problem of really multimodality is that the modalities really bear, I mean, some overlapping information, because cats and dogs are in language but are in reality as well. But some things are captured in some image modalities, for example, way more often than in others. For example, you don't see in text usually some things that you see in images really well, like how exactly like water spills. I don't think somebody in language described really the shape of the spillage of the water and how that evolves during time when the cup is falling. I mean, the language has a concept of water spilling, and that if you drop a glass of water, it spills and it breaks. But I don't think this really detail of how this all happens. This is something that images can capture for a frame of time, or videos can capture for many frames. And if you have this non-overlapping information, it's sometimes hard to align it. Sometimes hard to have a similar representation in image and in text, and to know that they're actually similar. For the model, it's sometimes really hard to figure that out. This is actually the same, or at least very similar, and they should land in a similar uh, region of the vector space. Yeah, that's the challenge of multimodality.
Yeah, that really inspires me to think about what kind of like AI art and entertainment will come out of all this. Is how it will be able to find these new visual things that you just never would have picked up on. And the kind of always on AI is super fascinating as well. I guess and on one end, I think we could go into discussion about why local AI feels so important, because you probably don't want every single thing you're doing like backed up on Google Cloud. But so I can see that. But then I also kind of, maybe one other topic I'd really like to explore is maybe the like an intermediate step to that, where it's like the ability of multimodal models like Gemini to parse our podcast and turn it into like structured data, or turn PDFs. That's probably the most common thing, but I see that one as being a more intermediate step. Like it would be such a contribution to AI. Like back in the day, if you were like, I took all the NeurIPS papers and I've just cleaned it. It's clean text. And so, yeah, that part is maybe what inspires me the most.
Yeah, interesting. Yeah, but coming to what you said before, I think it is important to have a local and your own personal AI, and therefore open source is very important, making these models efficient and hardware efficient, such that it can run locally and not only on OpenAI servers. Because yeah, people are always saying, and this is actually an idea that Jan LeCun has been preaching lately, that there is this people that are afraid that AGI is coming, and a bad guy will train an AGI that is super perfect at manipulating people. Maybe, but if I have my own AI on my shoulder, it first has to manipulate my AI, and then if it passes through my AI, it has to manipulate me. So it's a little bit like a spam folder. I'm not even reading what Nigerian princes write to me, because I have a spam folder, and I don't have to deal with that. This AI that is the spam filter dealt with that. Therefore, I don't think it's this so pessimistic approach to like the future of AI is valid when we think of that. Yes, there are bad actors in the world, but there's at least an equal amount of good actors in the world, and if we have open source and we have like this possibility to give everybody this own personal AI that is really your own, like your own mind, and it doesn't go with data into a certain cloud and so on, just keeps staying with you and being your buddy and having your back, then we can actually defend against most of these threats that people are so scared about when it comes to the future of like very intelligent AI.
Yeah, I think I've been kind of out of the loop on that one lately. Sorry, I thought like kind of the premise of the yeah, well, I like the super alignment kind of thinking, where it's like how do you contain something that's smarter than you, because by nature it's smarter than you, and then you give it agency, access to tools. Like the idea of letting the LLM just something that's always confused me is when the demo is it's buying a plane ticket for you. Like I don't want it to just decide to buy anything.
Yeah, well, but this has again the premise that we will use that tool when it's not ready to do that. Because when I want an AI assistant that really books a plane ticket for me, I want it to be reliable. Like if I hire a person, a secretary, to do that for me, I'm quite sure that it won't just use my credit card to buy makeup. I mean, it might happen, but it's I hired a person that is less likely to do so, right? And if I hear people like having these always bad examples of it, they're assuming that we will use it when it's not ready to. And unfortunately, it's sometimes already happening. Like there's this example of chatbots that are used instead of so if you have a helpline and like somebody has suicidal thoughts and you call this helpline, usually a human used to respond, and there's this company that has replaced the humans that respond with a chatbot. And of course the chatbot has the problem of of saying you should kill yourself, even if that's totally unadvisable to do. But here the problem is really the people, the bosses that were convinced that they can really do something, like they can replace the humans with the AI. And maybe we need a little bit of failure to realize that it's not the case, and people should start really testing these things before really rolling it out. And it's a little bit, we're captured by these people that try to build AI products and they promise the world, and it's not actually how it is. So we're in this hype bubble, and it a little bit needs to burst until we see that we have actually quite incompetent AI. We don't have AI that can really book a ticket for me, and not like in a reliable way where it wouldn't book a ticket when I don't need one, and where it wouldn't spend too much and so on. So I think that we will really use these things, or I hope we will use these things where we're actually ready to do that. And interestingly enough, I mean, yes, there are some failure cases, and there were some stupid bosses that were convinced that they can use AI where they actually can't. But in most of the world, I think it's even surprising of how, I mean, we know that AI is kind of stupid today because it actually didn't change the world already, right? I mean, we have now these models that can help you with homework. We have models. I mean, we have ChatGPT, but it's not like it changed the world. It didn't. It's actually in so little products and in so little in actual use cases that yeah, I mean, it's, I think that there's so much money in it. It has something to do with the bubble, and not exactly with the kind of value it can produce. It can produce way less value than people are telling you when they're trying to get venture money.
More vector databases. But
I mean, of course, they can help with everything, because I was thinking, like, when I'm writing code, it's way better with Copilot than without. But it's not like it can replace me, like, not at all. Like, I have to have the idea of what I want to do. And the cool thing about ChatGPT is that when you already know how to do something, and already you have a draft of something, it's very good at making it better. I'm not the best at English. It will make anything I write better English, but I cannot say write my next paper. What I can say, I can give it a draft of my already very good with many ideas paper, but it's not good English, and it will make better English, but it will not come up with like all these things. And so really it produces value, but it doesn't replace the entire act of research, the entire act of writing papers. Is just like a nice tool, like now spell checker is or was. Now we just have a better spell checker in a sense, right? So I didn't change the world. Therefore, I'm less scared of like people where they say it will, because it has made a lot of advancements. It has made, I mean, search has made a lot of things easier, and I can get a lot of information. I was telling in the beginning that I couldn't get a lot of information into like how to do YouTube, and how to build like have the legal means to do that. And even ChatGPT can now help in these cases. You can just ask it because it has so much knowledge. It's like a friend that almost did that in its life, but just did not to do it. So that can help, and it enables me to do something that before had a higher bar to success, but it didn't change the world.
yeah, I guess I think. Well, I really like what you. I think this comes back to earlier what we were talking about with the coding. It's very good at that because it's got like it has a ground truth to that. Whereas with customer chatbots or internal RAG, you have this really hard to measure notion of how helpful it is. Yeah, I guess I have a more positive sentiment. I've always been just like super positive on AI. It's like, but I guess and I think this is it's just also just inspiring me with this opportunity that we kind of like on the Weaviate podcast. It's like I feel like with Weaviate we're very fortunate to sort of like we do work with a lot of people who are building internal RAG with their documents, and it just makes me think like the potential of this hasn't been seen yet, but it certainly is on the way in my opinion, because I think especially with the multi-layer, that's why I like one thing about DSPy that I like a lot is the same thing I like about LangChain. I'm not trying to like not say I don't like that either, but it's just like chaining together the calls where it's like to do research, you need to break the task into all these subtasks. And I think that sort of evolution of building systems that break tasks into subtasks, even like productionizing this is really difficult with the streaming and the async support. Like what you would really need to build these kind of APIs. So I'm pretty optimistic
Yeah.
that we're just right there to that.
Yeah, well, and then I'm not saying I'm not optimistic, and because this is way better to have than not to have than before. It's just that even when you're chaining these calls, you are chaining these calls. You are saying how you break down the task. So it's still your human knowledge that went into it. It's your entropy, and then it took that, and the model just used it very nicely. It's a little bit like a smart employee, but you're still the boss and you still have to say what it should do. And then people who say that this is necessarily leading to the end of the world, I just think is a little bit exaggerated. But of course it does make a lot of things. I want to pay for a thing that can take my paper and make it way better formulated in English. But the problem is that I still have to write the paper, right? It's and that's even the cool thing, yeah, right? I want to do research, so it's not the problem. Is that we have smart employees, but it's and maybe they will become smarter than us, but it's not necessarily a bad thing to be a boss where your coworkers and your employees are better than you. It's just actually a very fortunate case to be in.
Mhm. Oh, that yeah, I agree 100% with that. It just will supercharge your own work, and I think take like the tedious parts out of your job out a little
Yeah,
bit more so
yeah,
than the
exactly.
yeah, definitely. Awesome. Letitia, thank you so much for joining the Weaviate podcast. It's been so much fun exploring these topics with you. Your YouTube channel, the AI Coffee Break with Letitia, it's amazing, and I've loved just keeping up with it over the years. And I really hope to welcome you back to the podcast, in the future, and again discuss all these things and how your journey is evolving. Thank you so much.
Thank you so much for your amazing questions, and I would be happy to be a second time here.
Awesome.